So hi everyone, Senan this side, and in this video we are going to see how to delete an element on the tail of a linked list, right? So this deletion is actually a three-part series. So this is the second part. In the previous video I discussed how to delete at head, and the video before that I have discussed all the theory behind this, how to delete at head, at tail, and somewhere in the middle. So in this we are going to implement this delete at tail or delete at end. So let's get started. So first we start by declaring delete at tail or delete at. Now you see these dots. This is because I have not actually given the implementation of that function. That is the reason why. The next thing is let's write the implementation. And if you're coming to this channel for the very first time, you need to know that I have separated the declaration, implementation, and the main. These are three separate files I'm working with. If you need to understand what is actually happening, watch the very first element or watch the very first video in the series. Okay, so we need to implement the delete at tail. So first what we do is declare the return type, then give the scope resolution operator, this one, double colon, and tell this that this delete at tail function is present in this linked list class. So let's get started. Okay, so there were three cases in the theory that I discussed. That is case number one is no elements in the list. So if there are no elements, you have to return, right? What was the case two? Exactly one element in linked list. So if there is exactly one element in a linked list, then we know that we have to update the head. And case three, the final case, where more than one element in the linked list. So that is the thing. So let's implement them one by one. So we have the access to this head, right? And if there are no elements, that means the head would be null. So if head is equal to null, you just return. The other way to check this is, rather than checking equal to null, you just check this. If not head, then return. So head is null, then not head would return you a true value. And if this is true, then you return. Now, when do you know that your list has exactly one element? So that would be the case where heads next is null, right? Or again, if heads next is null, what do you do? You cannot just return, but what you have to do is, before returning, you have to delete the head, and then the new head would actually be a null pointer. Delete this head, and since we don't have any next element to this head, we don't need a temporary to store that value as we would require in the case 3. So after deleting head, I just update to head is equal to null, and then I can just return. So if head is null, no elements, then you return. If there is exactly one element, you need to update the head, and then after that you can return. And finally, the case where you have more than one element in the linked list, what you do is first you need to reach the second last node. As we discussed in the theory, we need to reach the second last node, and to reach that we need a value. So before that, let's take a temporary node star and temp, which would be the head, right? So I know that head next is not null and head itself is not null, so I would have two elements at least. So if I check this while this condition, I check head or temp next is not null, that is what I need to check. It's not equal to null. What I would do is I would go to the next element. So temp is equal to temps next, fine. And not equal to null is same as checking this if this temp next is valid. So while this, you go to the next node, and using this you are actually jumping to the node which is the element just before the last element. And after this, what you do is you actually delete the last node, and when you delete the last node, there is no node after that. So what you need to do is the pointer that is at the second last element, that is pointing to a memory location, and that memory location that was allocated, we had already deleted that. So what we have to do is to mark the next of the second last as null, because we don't want any dangling pointers. So let's do that. First you take the temp and next, and this is the node which is the last node which we have to delete. So I'll just say delete temps next, and then I can assign the temps next equal to null, so that there is no problem with this. And because this is a void function, you return. It's always a good practice to return. And yep, that's it. you have written your delete at tail. So now let's just check this out if this is actually working well or not. So we have this implementation like in the last video. So I'll remove a lot of that. Okay, so this is initially printing the original list. We have 0 to 9, the numbers 0 to 9 in this list. So rather than deleting at head, let's delete at tail, and let's just print what is the output. So the compiler is g++ main.cpp, and since I am actually including this header file, which is my own declaration, I also need to give the implementation for this. So what I'll do is I'll just give the linked list.cpp. If you don't understand this, watch the very first video on insertion implementation. You'll get this, and let's just compile. Now after compilation, what I can do is just run this and see we have deleted the last element. What if I do this a couple of times? So for int I, from I that goes to 0 to, let's say 15, right? And what I do is I'll ll.delete at tail, and after that ll.print to see if this is working well or. Okay, so let's just compile this again and see if this is running as expected. So you see at every iteration, so the last couple of lines is just this print statement, because nothing actually happens in the delete statement, and because my print statement has a new line in this, you see right here we have a new line here. So that is why we are seeing so many lines, but that's not the issue here, or there is no issue here. So if you see 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, and then nothing. So this is working well, and even if you try to add something, this would work fine. So that was the video on deleting at tail. Watch the next video for the implementation for deleting anywhere in the list, right? It will be the head, it will be the tail, and somewhere in the middle given the position. So that's it, and I'll see you in the next video. Bye.